So surface area and volume of a sphere. There are two formulas, and they're on your formula sheet. I like the surface area formula. Again, once you get to AP Mathematics in grade 12, you have to have all your formulas memorized. So the more formulas you can start to memorize, the better. And if you can come up with a way to remember them, I find that that helps a little bit. So for example, surface area of a sphere. When I take a sphere like this golf ball and I look at it, I see a circle. Like if I was going to draw this on a page, it would draw as a flat circle, right? Now, something that's a flat circle, ooh, maybe I have some money. Do I have any? Oh, I might be broke. Nope. Here we go. Oh, look at this. I have a quarter. A quarter is a flat circle. It has some thickness, but if it was like just a piece of paper flat, if you wanted to do the surface area of a quarter, would a good estimate be just to add two circles? You would miss out on the tiny thin part on the side. But for a quarter, surface area as two circles would be pretty close. It's still a cylinder and would have a tiny height to it, but that would be pretty close to its surface area. So when I look at a sphere, I see a circle. You're looking at the same sphere as I am. You see a circle that I don't see. You see the backside. Now, if someone was looking above, they would see a circle that neither of us see, because they're seeing the circle that's the depth. And if someone was looking from underneath, they would see a circle that the other three people wouldn't see. And if we take each of those perspectives, front and back, above and below, we would get 4 circles. I use that as sort of an idea to help me remember that formula. And then the volume, area is always units squared, volume is units cubed, so we have radius cubed in our volume formula. So in this question it says to find the volume and surface area. I would say split your page up so we can do one side volume, one side surface area. And both of these have formulas that are really easy to use. Almost always with spheres, for both surface area and for volume, you would write out your formula and ask yourself if you have all the information that you need. For example, the information that you need here is just the radius, and sure enough, the question gave us the radius. So I can rewrite and plug in a radius of 12 in for the argument. So take out your calculator, practice putting this in. Here we go. And see if you get the same answer as I do. Then make sure we include our units. Check the question if they say anything about rounding. So this is the first time that we've used cubed. Do we know where to find the cube button on our calculator? Do we know how to type that in? It doesn't say how much to round. I'm going to go to 3 decimal places, 7238. 0.229. I'm going to add my units, centimeters cubed. Anybody have issues finding the cube button on their calculator? Or type something in and didn't come didn't come out to this quite right, you can ask me during class, you can come afterward and say, I think I'm having issues with my calculator. It's important that we know how to use our calculators, because if we're going to rely on them to get us the answers, and we put an error in, then that's going to be a problem moving forward. Surface area, same thing. We're going to write out the formula from our formula sheet. We're going to plug in what we know, go to our calculator, type this in exactly 1809.557. And this, that is supposed to be a 2 per squared. Put a square around both of my final answers there. And this question was straightforward because they gave us everything we needed directly. Our next question, we're not given everything that we need. So if we look at find the volume of a volleyball if its circumference is 26 inches. So first of all, we think about a ball and recognize that it's a sphere. So I'd write out my formula for a sphere, 4/3 pi r cubed, which means I need the radius in order to find the volume. I read the question, and they don't give me the radius. So I'm just going to make a note. We need the radius, but it's not given to us. What's given to us instead is the circumference. So that means we're going to have to somehow use the circumference to find the radius. If we're going to use the circumference to find the radius, we need a formula that has circumference and radius in it. Okay? You can look at your formula sheet for that. Again, the more of these formulas that you have memorized, the better. So on your formula sheet, there's a formula for circumference, that the distance around a circle is 2 pi r. So they tell us that the circumference is 2 pi r. We want to solve for r, and they tell us that the circumference is 26. So we can insert 26 in for C, and now we need to solve for r. Well, if I want to get this r by itself, I'm going to have to move the 2 and the pi to the other side. We have to do opposite operations. Can you see that that 2 and that pi is multiplying by the r? So the opposite of multiplying would be to divide. This side will simplify. And I'd like you to type this into your calculator and see what you get for r. Okay. Did you get 4.138? I'm going to put dot, 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 because I'm not wanting to round early. We're not done the question. So we try not to round early anytime we're not done the question. If you got the wrong answer on your calculator, remember that if you just do divide by 2 pi, depending on your calculator, you might have gotten 40. Right? So if you're just typing divide like this, and you got 40, you need to put, you're dividing by more than one thing, you would need brackets there to make sure that you get the full. If you do have a graphing calculator that gives you the fraction option that I just did, or you have a scientific calculator that allows you to write things as fractions, that gets rid of that bracket error. So it makes it a little bit easier. Again, learning the tricks of your calculator can save you tons of time and errors. So, we found the radius, right? We needed the radius. That's why we wrote a note. Like, why did I do this? Oh, I needed that. I need the radius. So I use the circumference to find the radius. I'm going to make a note. Now we can find the volume. So my volume is 4/3 pi r cubed, and now I can plug in and again, I'm going to put the 3 dots there to say I'm not going to round early. I'm going to show you a couple, in my opinion, really cool things that you can do with the calculator. So you might like this. Probably the most common thing that students do in a situation like this is they start typing in 4/3 and then pi and then bracket, and they take this answer that they had from before. Most commonly, I like to just go second answer. So I'm going to do this first. So I want second answer, that pulled my answer from before, and I want that cubed. I guess my answer, 296.804. Does it ask me to round in this question? And notice I'm only rounding now right at the end. Read the question again. Nope. So I'm going to put 3 decimal places and round it to 3 decimal places. And the units were inches, so it becomes inches cubed, square round. There's my final answer. Same as on the calculator, 296.804. Another thing that students sometimes like to do, so 4 divided by 3 with this calculator. And almost every calculator has a way to get the answer from before. So I'm going to go back to this answer and push enter, and it also writes it in for me. And it does remember more decimal places than even are showed there. So if I go cubed in this place, I get the same answer again. One last thing that's really cool, I'm going to take that, I'm going to type that, I'm going to type that in again. On your calculator, above the on button is a store button. So if you have the graphing calculator, and you hit the store button, it lets you store that as any letter you'd like. Often I just use the X button right beside the alpha button because it's close. But this time, since it's my radius, I'm going to go alpha, and then R is here. I'm going to store it as R. If it's stored as R, when I type in 4/3, I can go pi, and now I can go alpha R cubed. It gets me that same answer again. If you have a graphing calculator, almost all of your letters are originally stored as zeros. Right? One thing you can do, like I can go 1, I'm going to store that. I'm going to go 2. I'm going to store 2 as J. I can do this, and I'm going to store 5 as R. There we go. Right? And I can check, I don't know what, I'm curious, I think some letters I've probably never used. So if I take Sam, for example, here, if I just type in your name, Sam, right? M, and I push enter to see what I get. Oh, Sam's a 0. But Mr. JR, you can probably guess, oh my goodness, did I set myself up to be a 10? No, like, little trick you can play on your friends. Most of the, if you have a graphing calculator, most of the letters are preset at 0, so you type in your friend's name and you can set up your name to be whatever you want. 100 maybe, if you want to be even higher than me, that'd be perfectly fine. Little jokes. Okay. So there is our volume here. So sometimes we look at our formula, right? If I want to find the volume, I need all the other variables, which is only the radius. But I didn't have the radius. So then that tells you, okay, I need the radius. What did they give me? They gave me the circumference. So I'm going to use the circumference to find the radius. So then I look in my circumference formula. Sure enough, I have it. There's the radius that I need. Plug in the circumference, found my radius. But I don't round early because that could cause my final answer to be off. In my work, I just showed that I'm keeping everything by just going dot, dot, dot. Everything's going to be there. Sometimes we can write exact values. So sometimes people just leave it as 26 over 2 pi. Or, you see that 26 would reduce to 26 over 2 would reduce to 13. You could just have written this as 13 over pi and kept it as an exact number. Oh, that's another way I could have done this. So look, notice I could have done 4 divided by 3 pi, and then instead of using the decimals or using all of the stuff or using r, I could have put in 13 over pi, bracket, and cube that. I get the same answer again. But there I was using exact numbers all the way through. And once you get to university, they'll just say, just leave it like this. Don't change anything. Because you don't have a calculator, you could just leave your answer as the instructions you need to give your calculator, right? That's the instructions for what I need to push into my calculator to get the answer, and universities would say, that's the answer you need to provide. Take out your formula sheet and see if hemisphere is listed as a formula. Oh, I'm going to leave a little space in the middle here. I'm going to draw a hemisphere for you. Can you visualize that? Maybe if I paint the top of it with, oh, because we cut it in half. Sorry. My sphere is bleeding a little bit when I cut it in half, so I color the top red. I don't know if spheres bleed. Okay, there's my hemisphere, which is half of a sphere. Is that on your formula sheet? No. Any idea how we could figure out volume if it's not on our formula sheet? Yes.
Calculate the volume of the sphere and divide by 2.
Yeah. So we're just going to take half of a sphere. Woo. We can. So the volume of my sphere, I could calculate that. And maybe one of the things that we sometimes do is we write, and you see this on your formula sheet, a little tiny word underneath the volume. So like, this is my sphere. It's going to equal 4/3 pi. Do they give me the radius? Yes. It's 5 cubed. $523.598. So then next I can write volume with the little word hemisphere there, and I just need to cut that in half. So if I just push my divide button, it says, what would you like? Since you start with a command, it automatically picked up my answer, and I just want to divide my answer by 2. 261.799. Does it ask us to round to something? No. And our units were centimeters. Volume is cubed. Double check my calculator, I copied it down right, and I did. Great strategy. Hemisphere, half of a sphere. Next question, we're going to do the same thing with surface area, or are we going to do something different? Let's do surface area. Let's do our surface area next. Is it going to be exactly the same? Can we just take the surface area of the sphere and cut it in half? How come? What's wrong? It's almost right to just cut it in half, but then when you cut it in half, the red part gets added. Does that make sense? So you're going to take idea here, if I take half the surface area of the sphere and I color code this, imagine your sphere was originally painted blue. Half of it would be the blue part that you see, but the red part wasn't part of the surface area originally. It was hidden inside the sphere. So we have to take half the surface area of the sphere, that's the blue part, and add a circle. If I underline this part in blue, and this part in red, then the picture kind of tells us why that happens. So surface area is always, in my opinion, a little bit more difficult than volume. It involves a little bit more thinking, because you'll have more things involved. So, if I use the idea, I could start off with my surface area of my sphere, (4 pi r squared), and I could actually figure out the number and cut it in half. Okay? This is a preference thing. For me, for preference, I often like to do some of the simplifying first before I find out the numbers. But I'll do it in both ways and you can decide which you like better. So method number 1 is I'm going to figure out the numbers, because that's probably more typical of what people try the first time they do it. So that's probably what you would do the first time. I'm going to show you that. Then I'm going to show you a simplification method, and you can decide which way you like better, analyze them both, and see what you want to do. So, surface area of the sphere, right? I'm going to take that, I'm going to calculate it. My radius is 5. Is that we calculated the surface area of the sphere and got 314.159. And then we said the surface area of the hemisphere will be half of that plus a circle. So I'm going to type that in right away. And I can take half of this answer, so I can go my answer divided by 2, plus I'm going to need to add a circle to this, so it's like pi, the radius is still 5 squared, and I get 235.619. 235.619 centimeters, and its surface area. But the other way that we could do this is with formulas. If I take half of the whole sphere and add the circle, which is a pi r squared, does it make sense that half of 4 is 2 pi r squared, and you add the circle, which is another pi r squared? And if we simplify the formula, we can actually find a simplified version of the formula for the surface area of the hemisphere. Because if you have 2 pi r squareds and you add another pi r squared, like terms, does it make sense that you would have 3 pi r squareds as a result? And if I type that into my calculator to check, notice that I get exactly the same answer as before. So I kind of like simplifying that formula and be like, well, if normally a hemisphere is 4 circles, and I do half of that, the blue part would then be just 2 circles. But I have to add a circle on the top, giving me 3 circles that I would have to add together to get my whole surface area.
Can you call me over to the office, please? Ms. Anderson, Mr. Dickerson, Mr. Atienza, Mr. Edwards.
So the questions we've been doing so far have all been ones where you get the information and you have to find either the surface area or the volume. Sometimes you'll get a question where you get that surface area or volume and they want you to find something about the shape, one of its original features. In this case, the diameter. So we've got surface area, we know it's a sphere. In our head, we could think, okay, I know that the surface area of a sphere is 4 pi r squared. So if I know the actual value of the surface area, which is 250, I could plug that in. And if I plug that into the formula, I notice that the only thing I don't know is the r. So I can use my algebra skills to solve for that r, which means I can find the radius. Would finding the radius help me find the diameter? Because the question wants me to find the diameter. Yes, because if I know the radius, then I could just double it to find the diameter. So I wrote up the formula and plugged in what I knew to see what would that help me find. And does it help me find something that I need or could help me find or solve this question? And the answer is yes. So now I'm going to get this r squared by itself right? I'm multiplying by 4 pi, so the opposite would be dividing by 4 pi. Again, type this into your calculator, see if you get the same answer as I do. $19.894. And then the r by itself, what's the opposite of squaring? I would have to square root both sides. So again, I go to my calculator, I go second square root my answer, and I get r is 4.460. And I can now write the diameter is, and I just have to take my radius and double it, 8.921. And we're going to look at our question to the nearest tenth of an inch, so I can just round it. My final answer, I'll put a box around it. And the last question that we have for today connects what we're going to be doing in the last section with what we're doing right now. Right? We have a storage tank, and can you see that this storage tank is a cylinder, but then it has a sphere put on either side? And we're asked to find the volume of this whole thing. Okay? Sometimes I find that these questions you have to be a little bit careful and read them carefully about where the numbers are going to be. Okay? I think that this part here, when you read this, the length of 8 feet, the question you have to ask, in the context of this question, does that mean the whole thing is 8 from here to here? Or is it just 8 from here to here? If we read the question carefully, it has a cylinder with a length of 8, so that 8 only goes from there to there. The radius of the sphere is 2. The idea can you see that the two ends you could stick together and get one sphere and then the cylinder, and if you added the one sphere and the cylinder together, you would get the volume of the whole thing. So again, we put the shapes together, think about the formulas that we have, and I can write this out, total volume, now I'm going to write it as formulas. My volume of my cylinder, my formula for that was pi r squared times h, and my volume of a sphere was 4/3 pi r cubed. So I need the radius of the cylinder and its height, and I need the radius of the sphere. Luckily, all of that information is given to us. On the cylinder, the radius is 2, the height is 8, because it's turned on its side. For the sphere, the radius is still the same 2. And even though this is super long, you can type all of that into your calculator at once. So I'm gonna go pi, bracket, 2, black dot squared, bracket, 8, plus 4/3 pi, bracket, 2, cubed. So I wrote in exactly what I saw here into my calculator. I just have to push enter once. 134.041. Does the question say how much I want to round to? Nope. We need to put units. It's volume, so it'll be feet cubed. And we can put a square around our answer.